I know it is extra credit, but just in case someone shows you or the cat writes a problem and says, hey, they don't know what the roots are, right? Mm-hmm. And I feel and say that you might see something similar where they don't have the roots. Remember they go x1 is this and you got to find the other guy. Or they give you both of them to approximate in between. Well, what happens, Michael, if they give you like this? And you're like, oh, I don't know what roots to use, right? Yeah, exactly. Well, here's the catch, right? The biggest thing is, let's say that they give f of x is this guy right here, this cubic, okay? Whatever it is, x cubed minus 2x and so on. And the biggest thing is all right, well, I got to find the roots where there's a sign change. Hint, wiggle, wiggle, sign change, right? So the biggest thing is how do you actually find or test for what the roots can be for this? Yes, Mr. Bell?
Can you move over the 6 and then factor out an x?
Yeah, you can if you want, but I recommend using what's called the rational root test. Let's call it RAT. Is that okay? RTT. I call it RAT, rational RRT. Okay? And the rational root test says, I look at the last guy, the smallest dude there. Let's call that a Q. And then we call this guy the coefficient, numerical coefficient in front of the biggest guy. Let's call that P. And HIT says, you take all the factors of Q, and then you divide by all the factors of P. Plus or minus, of course, right? Make sense? You've seen this before, haven't you? And if you haven't, that's roughly. So all the factors of Q over all the factors of P. Not bad? Pretty good so far?
But it takes a lot of time.
It doesn't.
I kind of remember this.
Yes, okay. It's a fundamental theorem of algebra as well, and so on. So what are all the factors of 6?
1, 6, 2, 3.
Right.
Yeah.
1, 2, 3, and 6, yes? And you have to use plus or minus, right?
Yeah.
Now, what about 1? Well, duh, 1 plus or
1.
minus 1. Has no bearing on it, right?
Right.
No effect. So it's just all of these. 1, 2, 3, and 6. Now, they call 6 what's called a perfect number. Anybody know why it's called a perfect number besides, he says it? Perfect number in mathematics is a number that you take away the last of the factors, so to speak, and add up all the remaining factors to get that remaining factor. So 1 plus 2 plus 3 is 6, right? The next one is 28, okay? The next one is 496. And I think the next one took about, from then, the fourth one, Euler found it out, but it took like over 400 years. And then after that, there was like a 1,000-year gap to find the next perfect number. But that's just outside the thing. Yes?
So if the bottom had been like variations,
You got to do,
like multiple ones?
yeah, because you could have, let's say that was a 2, right? He's right. And then it'd be plus or minus 2, okay?
And then so
Then
one
you got to
divided.
do all the plus or
Yeah.
minus 1. Right. Absolutely correct. Now, I won't be that miserable to you, okay? But Cambridge is evil, so they can do that to you, okay? But the worst thing I can say here, Ms. Abear and Company, is like, well, man, he didn't give us the roots. What gives, right? Well, it's not me. It's them. So I want to just cover myself so you guys know what. Oh, I remember what that crazy guy said. The one with the one arm now. Yeah, exactly, that guy. Okay? So we know it's all these guys. Pretty good? Well, all you have to do next is you can do synthetic division. I recommend you don't do that. You just go, well, let's go f of 1. We're looking for what? A sign change. What are we looking for?
Sign change.
What again?
Sign change.
Louder.
Sign change.
Sign change. Exactly. You're looking for a sign change. So you put in 1, and you have to see that step in between, and then you got it. Well, if you put f of 1 in there, you're going to get a negative. Okay. Whatever the value is, right?
Right.
You can see right away I'm not interested. Okay. Then I put an f of minus 1, I still get a negative. Nope, no sign change. No sign change, right? Then I go f of 2, I'll skip to it. F of 2 gives me, what does it give me? I don't know. Oh, it gives me, hold on. F of 2 gives me a minus 2. Well, that's greater than 0. That's a check. And then there's 3 and a minus 3, right? And save some time, we go f of 3. And then lo and behold, we get a positive. And that positive is going to be 12. Greater than 0. Greater. There it is.
So we're looking for something to be greater than 0?
We're looking for one that's a positive root, remember?
Yeah.
Remember my little cheesy picture here? You're looking, it doesn't matter where the sign changes, right?
Yeah.
So the root has to be between those two values, says high, and in this situation it is between, in my opinion, 2 and 3. This is what we consider alpha.
Okay.
It's in there somewhere, right? He's in there.
So-
He, she, it, whatever. Go ahead.
Why do we pick 2 though? Because isn't
Well, we just
that-
arbitrarily picked it,
Oh,
okay?
it doesn't matter.
Doesn't matter, you go all the way through them.
Okay.
Yes, sir.
So how many times do you recommend going through that before you realize that either there isn't going to be a...
Well, that's a good
Okay.
question. I think by trial and error is the only perfect way to do it. Yes, go.
So what we found one of the roots, right?
We found that there's a root that exists between 2 and 3.
Oh, yeah.
We know it's somewhere in between there.
What about the other 3? Because if it's x to the 3, doesn't that mean there's that many roots?
We don't care about that, right? We're looking for alpha. Alpha is where this thing converges, right? To satisfy this thing. Remember? We don't care about anything else. We don't care about nothing else other than finding that sign change. Yes, we can find the other roots that that answer this question, which is this guy right here. Yeah. We can do synthetic division and it works, but who cares? We don't want that. We want an iteration that gives us a value for x of n plus 1 and x of n.
Okay.
That's all we care about. Yes, Ryan, you're right.
Okay.
But we don't care. We want to get the points and get out of Dodge and go have Merry Christmas. Okay? And sing holidays and so on. Yes, sir.
Wait, so what's that formula? The x n plus 1?
That's what they gave you. This is on the sheet for
Okay.
number 4. Okay?
That's a gift. That's-
Okay? It's on number 4. It's the review. It's when there's what's called no given root. Okay? What if they don't give you a root? And you're like, oh, man. Right? You remember they said, well, it's between 2 and 3, right?
Yeah.
Then you know what to do. Or they say this, right? You have to determine it between those two, right? So this is where they give you nothing.
So now we have to find the boundaries.
You found the boundaries,
and
check.
then plug in the
Now you start doing the stuff here, right? Remember, you test the root, or test and find the root. That's 1A, 1B, right? Second one is to flip this to make it look like something else, remember? And the third one is to do the classic iteration.
What are we flipping?
Yeah, I'll show you in a second. You're going to have to
On the
prove.
very last page.
Yeah, the very last
The
page.
second number.
Show that this thing is the iteration formula, okay? Now, we're going to do exactly what Mr. Epler said, okay? Remember, whenever you see what's a iteration, you're going to do the following things. Check for a root, check for the sign change, then manipulate the equation that one looks like the other, and the third possibility is to do the classical plug and chug the values in there to get it between certain decimals. Okay? 1, 2, 3. All right? No big deal there. How are we doing? So we just did the first part, right? Consecutive integers. Well, that looks like consecutive integers to me, right? And they even help you pointed it out, right? So if it was like a -1 and a 4 with a sign change, consecutive integers.
So it has to be between
2 and 3, 3 and 4, whatever it is, okay? And if you got 4.7 or whatever, no, integer, right? Or -1 and -2, etc. Okay? Now, integer is a z, but you don't have to know that, okay? All right, any questions on letter I?
No.
Pretty straightforward? Okay. Not bad. Okay, now double I says, hey, you start off with this given equation on top, make it look something like this. Okay, so here we go. That's why I'm saving some room, as you can see. X cubed minus x squared minus 6 equals 0. I got to convert it into this ugliness, yes? Okay? Yeah, ugh. So the first step would be what, in your opinion? I heard it.
Move the 6 over.
Yeah, add 6 to both sides. Too smart, right? X cubed minus x squared. Now notice that there's a positive 6, right? Yeah. I'm going to put the 6 right over there. Okay? 6 positive there, 6 there. Yeah? Uh-huh. Now what?
Factor out an x.
Yeah, we can do that. Okay.
An x squared, actually.
Yeah, we can, yes, we can do that as well. Factor out an x. If we factor out an
How do you
x.
get an x to the n though?
Yeah, we don't throw the n's away. The n and the n plus 1. Just make it without the n plus the iteration clauses. Okay, now what? Well, the first thing they do is they divide everything. See this right here?
Yeah.
See that right there? And then whatever square root.
So-
They divided everything by just x. Okay, because if I don't, then I'm not going to get that square root, right? I got to make this mimic what's over here. Right? Not bad? I got to make this thing look like this guy. So in this situation, I'm going to divide everything by x squared.
Okay.
Or am I going to divide everything by
Just
x?
x.
No,
Just x. Just x. I'm ahead of myself. So now here we go. Ready? So we're going to get x squared minus x equals 6 over x. Not bad. Oh, positive there. So we're gonna add x to both sides. Hey, it's looking pretty good, Murmer. Yeah, it is. So that means you're gonna go x squared equals x plus x, 6 over x.
And then we just have to square root.
Now
Yeah.
you take the cube square root, and there it is. Plus or minus, and we just throw it away. We don't care about the negative. So we just have x plus 6 over x. Remember, so you can manipulate that thing, okay? I gotta make that original equation look like the extra crispy or whatever you wanna say. Okay? Or the hot and spicy or whatever, all right? It's the same thing, but you gotta manipulate it. If you don't manipulate it, then you're gonna lose how many points, whatever it was, okay? Yeah, we were doing sines and cosines and everything else, right? Okay? Sometimes you take the derivative, yes. Okay, didn't we do that before? Yeah. But this one's even easier. Okay, part 2 is out of the way, yes? Now, I did iterations, I do by English. All right, we already have our roots and so on. Now, ladies and gentlemen, does it matter what alpha is? We can say 2 or 3, right?
Yeah.
So, okay, which one do you want?
2.
2.
Yeah, I agree. I like the lower one because I know it's going to go up a little bit. Okay, and if I took the larger one, Sophia and Company, then I know it's going to go down. Right? Yeah, you can do the same thing. So you know x1 is what? 2, because you told me it's 2, right? So that means we go and use this formula right here. So I'm going to write it above. And now I know the board's filled with a lot of boring stuff up there. Yeah, it's not boring to me. But you get the idea. So now this is going to be x2. We're going to plug it right there. So x3 is going to be equal to the square root of 2 plus 6 over 2. Oh, here we go.
But how does the other formula that we
Hold on.
need?
So this one gets right here, right? So what do you get here, approximately?
2.2361.
2.236. Oh, and they said 4. I don't know how many places, right?
5.
5. 1, 2, 3, 4,
Oh, they said 5? So 6. Oh,
7. Right? Pretty easy so far. Now, 2 you don't use anymore, right? You know it's going to be starting to come around this guy, right? So that means this is my x3, right? So then I take the x3 and I plug it back in, right? So that means I'm going to go x4 equals the square root of 2.23607 plus 6 over 2.23607. And you're going to tell me what that value is,
And then you take that value, plug it in, get an answer, etc.
etc.
795.
21796, I heard.
Yeah.
That looks good enough for me. Okay.
Question.
Yes, question.
The previous, like, what was the equation that we made, like the last problem? Yeah, whatever. How does that play into this, or do they not have any connection?
How does what?
How do they correlate with each other? Or do they,
Well, they're the same thing. You just solve for x on one side.
oh.
So you generate this guy. You generate the iterative. Okay, that's really it's called.
Okay.
You generate that sucker. They want to know if they're both the same.
Alright.
Okay. Now you take that guy, and anybody just to save some time, what'd you get for x5?
2.18816.
2.21.
21.
21.
Yeah.
88 what?
882.
2. Okay. All right. Now it says to round to 3 places, right?
Yeah.
So you probably would do another one
Yeah.
if you want. I would do x6 to make life easy. And they got, well, that's x5, right?
Yeah.
2188. Well, they got 77. I'm not sure.
Yeah, that's right.
That's what they got for x5? Yeah. 21877. That's right.
Yeah.
And then this one is 2.21878.
2.22.
That's not.
2.21878, right? So they want you to round to 3 places,
Yeah,
right?
so just 2.218.
2.219.
9.
9. I can write the things in a second, right? You throw away the 2. 2 3's too high. 21796. They got a 21882. I guess I forgot another one in here. They want maybe another one. X4 came out to 21.
I got 21881 for X4.
Oh, this is X1. This is X2. And then X3. X3 comes out to, I'll write the values, okay? 2.23607, okay? 2.21796. 2.21882. 2.2188. 77. And then finally 2.21878. 878.
So would
Okay?
it just be 2?
X2, excuse me, sorry.
Oh, never
X2,
mind.
3, 4, 5, 6,
Okay.
2, 1. There we go. It's
So-
converging. See it?
So it's 2.219?
Correct.
Okay.
Okay, I just wanted to prove it to you.
Yep.
And then, all right, let's stop right there on that one. Okay? Not bad? So, remember, they don't give you the roots of the bounds or whatever it is, then you generate them by using the rational root theorem. You look for that sign change, and then you read what it says, oh, consecutive integers, or whatever it is, right? Yes, sir?
Plus, when you get the final answer, you plug it back into the original equation, and if you get 0, then there you go.
Do we have to? We don't have to do
No,
that.
you don't have to, but that's another good check.
Okay.
You do not have to do it. But you do these 3 steps to get all those points, whatever they were, okay?
Okay.
All right?
Yep.
Yeah.
Any questions? So I covered my basis with all you
7
guys,
points.
that you never miss this one. Oh man, they don't give us the roots, right? You got it. Oh, they give us a boundary to start the plus or minus.
Thank
Got it. Oh, I got to manipulate the equation. I know how to do that. Oh, I might have to take the derivative. You know, you take the derivative here, you're not going to get it. But like the sine and cosine stuff, you remember we did the derivative? I can't remember. Okay, and then finally you just plug and chug, and then you see where it converges. Yes, sir.
So number 1 on the review sheet is kind of like that with the part I, but then like they
Number
didn't.
1 on the review sheet. Sammy's review?
No, the very front of the
I
review
gotta
sheet.
find my
Miss K.
They choose 2.
Mrs. K's.
Yeah.
Yeah, they choose 2.
Number
given
one?
that 2LN.
That's
Yeah.
2L. Yeah, she does. What she does there, we can go over that if you want.
Yes.
I wanted to go over trapezium, but all right, fine.
Or if you want to,
LNs, it
yeah.
scares us.
Oh, Ellen, can I erase?
Yeah.
Sophia, okay?
Trapezium isn't gonna be
All right.
Yeah.
That's not a bad one to ask, right? It's not a bad one to ask, okay? Now, I think that all you got to do is remember logs are exponents, okay? So, now this is what they give you, right? 1 on the review. Okay? So they give this to you, 2 ln of whatever,
Yeah.
domain, plus ln of whatever,
Uh huh.
equals 3 ln of 3?
Yes.
Okay. Remember, logs are what? No different than exponents, right?
Yes.
And log property says that we can go backwards. We can work backwards, right? So you see that thing right there? Right? Put it back to the base, so to speak. Yes? That's your power rule for your logs, right? And a plus sign means what, ladies and gentlemen?
Add.
Which means in exponent world, multiply. And subtraction means what? Divide. So that means these 2 things are doing what? They're multiplying, right?
Yeah.
So I can bring these together if you want. I can do it all in one step if you want. You want to do little, oh, okay, fine. So here we have baby steps, natural log, that's okay. 4x minus 5 squared plus natural log of x plus 1. Yeah? Equals, whoop, natural log of 3 to the 3rd. Yes. Yes, Mr. Allen.
So is this number I or I?
I don't know, whatever it is, number 1, isn't it?
Yeah,
On
it's
Mrs.
I.
K's.
It's I.
It's I.
One
Yeah,
of
here it
them.
is.
We're just showing that it's equal to this.
Equal to that thing there, and I'm going to prove that in a second, okay? Now, this means to do what right again?
Multiply.
Multiply. So that means natural log of 4x minus 5 squared times. Remember, this whole thing is in the log thing, right? X plus 1 equals, what's 3 to the 3rd?
27.
Last time I knew it was 27, right?
Yep.
Okay, now, how are we looking so far? All right, pretty good? Yes. Pretty good?
Yes.
Yes. Now, we take, and you're going to be like my grandmother here, and you're going to say Al. My grandfather's name was Al. My grandmother used to call it all the time. Al, anti-log. Right? Yeah. Okay. So that means these guys kill each other off, right? And then now it's just going to be 4x minus 5 times x plus 1 equals 27.
Squared.
Squared there. Thank you. You beat me to it. Okay, so far?
Now we just.
Now you expand it and then rock and roll. I can do that if you want.
So
Yes, ma'am?
anti-log just like divide by log kind of thing. But like just
If
like
there's
one-
log on both sides, yes.
Okay.
Yes. Remember, there's a little e there. Hello, e. Hello.
Yeah.
Right? You just don't write. You're lazy. If there's log on both sides, it absolutely. Now watch the difference here, okay? She's brought up a great point as usual. She's like, oh man. How about just 27 there, ma'am? Now you just do what? 1, 2, 3. Remember? It's e to the 27th equals that ugliness.
Yeah.
Yeah.
Okay? Notice the difference.
So,
Oh,
do you-
Okay?
yeah, okay.
Notice the difference. There's a huge, oh my goodness, because what happens if they did this to you? Then you would just go, well, at 4x minus 5 squared equals 27. Oh, heck no. All right?
Okay.
Yeah, because there's not a loggy on the other side, or a natural log. All right? Great question. Yes, sir. Yes, ma'am.
do you remember last year when we were doing, we had weird exponents like x squared plus 1, and we had, so we had to make the denominators, or not the denominators,
Oh, okay. I'm sorry. I'm writing things.
we had to make both sides equal with the.
Yeah, base, were the bases different?
Bases.
Yeah, so
They make
she's
the
talking
bases.
something like this, right?
But if-
You take the natural log or the natural common log, yeah, and then this thing pops down,
Well,
and
the way
then
I
you
was-
equate the
The way I was
logs.
thinking of it is, if those bottom ones are the same, then you just ignore them.
Ignore
and
them,
use-
cancel them out. You
Yeah.
equate it, in other words, yeah.
You remember
So
that?
you expand
Yeah.
this guy right here, and you're gonna get 16x squared minus 40x to save some time, plus 25, and you're gonna multiply that by x plus 1. 4x minus 5. I square this thing, I square the bottom, and that's 25 if I'm right, 25. Okay, and then I take these two and multiply them together and then multiply by 2. If you wanted to, right? If not, FOIL it, right? And if you need me to do that, I can. Then you just do foiling again, right? And that's 27. To save some time and so on, you rearrange terms and everything else. Then you get 16x cubed. Remember, because 16x squared times x is 16x cubed, right? Yes it is. And then, look at this, 25 times 1 is a positive 25, subtracted from 27. Bring that minus 27 to the other side is a minus 2. So there's your bookends, right? Minus 24x when you do x squared, minus 15x minus 2 equals Zippo. Okay, the rest is just rearranging and algebra that you can do sleeping. If not, then I can do all the rest of it for you if you wish. It's okay. It's okay to tell me, you know what, I need you to, could you please, or whatever.
Wait, isn't it a plus 2? No.
It's a plus 2 on this. I brought everything over, sir.
Yeah,
Okay?
yeah, plus
And then I subtracted 27. Remember, this, watch this, 25 here, right? And then subtract 27.
Alright, my bad.
Now you're better.
I got it.
Remember, I'm lazy. Who the heck would think of this stuff? Right?
So now the second part is using the factor theorem.
Yeah,
We just
now
really
you're doing
The PQ.
Yeah.
the PQ stuff, right? And that takes a while, right? Okay, you asked for it. Did they ask for it? Ms. Schultz, they asked for it. Don't look at me. Right? They asked for it. Yes, ma'am.
This is going back to like
Which
the
one
first
is
year.
the,
Which one's P, which one's Q?
yeah.
All right.
Or is it just the third?
It doesn't matter how you label them, as long as you do it right. Okay?
Uh,
So,
That's Q,
that's Q,
and that's P.
and that's P. Think
Oh,
of the
It's
alphabet.
the biggest and the smallest? Like, kind of thing?
Think of it this way.
Slash Q. P comes.
Think of it as the alphabet. P comes before Q.
So-
That's the best way to do it. And you can do it exactly what she was alluding to. This is a
whoever has
smaller
the-
power,
okay,
because it's
yeah.
x to the 0 versus x to the third,
Yeah.
right? And that's fine. So to do all the roots, it's going to be what? Well, plus or minus. I write this, okay, in parentheses. Then all the factors of 16, right?
So it's Q
1,
over P.
2, 4, 8, 16. You must try every one of them out until you hit a 0, right? That's the one that takes the longest time, okay? And once you get a 0, then you got it.
So,
And then we have plus or minus 1.
So, okay,
okay.
you take a look at this guy right here, right?
Yeah.
You just take a look at 1, okay? And the signs are going to flip either way, it doesn't matter. Okay? So 1, minus 1. 1, 2, minus 2, okay? And if you get a 0, you stop, and then you use synthetic division. So, to save some time, right, let's try x equals 2. We plug it into here. Okay? Everybody all right? All right. So then you go 16 times, 2 to the third. You just say, okay, you know what's going to work because I alluded it to it, right? 2 squared minus 15, remember 15 times 2, minus 2, and that comes out to good old 0. Bing, bing, bing. This one right here, right?
So,
Yes, ma'am.
so first what you do is you divide all the things, and then
You
you
put,
plug
yeah,
it in.
you right.
Okay.
See, it's 1 there, right? I want you, then it's going to be 1/2, then 1. I just right away do the 1, right?
Yep.
I don't do all this ugliness yet, right? I want to see if that I get an integer. Yes, sir.
So would being equal to 0 be considered a sign change?
Being equal to 0. Yes, it would be, actually.
Is the root.
It is the root. It's
We
one
don't
of the
have
roots,
balance,
right?
we just have the
It's one of
root.
the roots, yeah. Yeah.
So if another one's positive or negative, then we know that we've got a sign change.
Yeah. Yes.
I think
Yes, you're
two-
getting, or an inflection point, yes. You're getting into
Negative
calculus.
or positive.
Pardon me?
Is that for 2 negative or positive?
Now, this is for when x equals 2, okay?
Yeah, so
Now, the synthetic division, right? You got to do what? That's when x equals 2. Remember?
yeah.
So, okay, x equals 2, right? That means you got to bring this to the other side. So that means you must use minus 2 as your divisor.
What? Oh, yeah, I get it.
Uh-oh.
That makes sense.
Wait, what?
Wait, we have to do
No,
synthetic
it's
division
x
though?
plus 2 and then
You got to change the divisor, right?
yeah, you
You
just
remember
put it
doing that
backwards.
stuff? I did it backwards?
Yeah, because it would be x plus 2.
Oh,
Yeah.
so you're saying this is x plus 2? I remember she changed the sign, but maybe she
So
didn't change the sign.
if
That's
the
how
root
we-
is
Oh, you
2,
guys did it.
we put
Okay, so it's
actual
2.
root there.
All right. I used to change the sign, but it won't. Okay, so 2, right?
We only
And then-
change the sign if we have
If we have a parenthesis set, like an x
That's
minus
fine.
2, then we make it
Then you
positive.
do it. So now you just plug this in here, right? You go 16, right? Minus 24. So am I doing this right now? And then minus 15. And then it goes 3, 2, 1, and x 0, right? And then that's going to be a 2. Minus 2. There it is. Drop it like it's hot. All right?
I think you're the one who taught us.
Of course I did. 32. And then it comes out to be 8. Multiply. 16 minus 1. Is that right? Minus 1.
Plus negative
Plus
2,
1.
plus 0.
Plus 1. And then 2. Bing, 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 0.
What was the first step of the synthetic thing?
Okay, so you take the root, whatever it was, came out to 0. And that's your divisor.
Oh, that's an arrow. I was gonna say what's
That's
our
an arrow. I
16?
just- it just meant
Drop
to-
the 16.
Yeah.
Then multiply.
Okay?
Someone Georgia takes some.
I think it's.
This is really, guys, I was right. You're really dividing long division wise by x minus 2,
Yeah,
right?
that's what we're saying.
Okay, yeah. Long division wise, you're doing that. Now, remember, guys, if you're doing long division, I recommend when you do the dividend, write it exactly the way you see it. See what I'm doing? Look familiar?
Yeah.
Yeah.
So, okay, the
Go ahead,
answer is gonna be- Do we just leave it like that? Or we
No.
put X's in? Yeah.
Why are we dividing?
Why are we dividing?
16x.
Go ahead, I'm sorry.
Squared.
Oh, guys, could I hear Emily? Yes, ma'am. Go ahead.
Okay, so it's 16x squared. 8.
Yeah, so it's 1 power less than the divisor, the dividend, right? So it's 16x squared plus 8x
Plus 1.
plus 1, right?
Yeah.
Okay.
Why are we?
Now you factor,
And then
right?
we trinomialize
Oh, we set
that.
Oh, we're factorizing.
4x, 4x, I'm gonna try, and then 1 and 1, right? And that's what it wanted, right? So the answer, if you wanted to write it, would be, in my opinion, x minus 2 factorized, and 4x plus 1 quantity squared. Game over.
Oh.
I'm
yeah.
just lazy. I'm just lazy.
Yeah.
All right? Because I want to get to my trapezium. How much time do I got for traps? 10 minutes, 20 minutes?
That's enough time.
Plenty of time? Okay, good.
Wait a minute.
I wrote this all.
Traps don't deserve a lot
Isn't there a
of time.
third part?
Pardon me?
Is there a third part?
I couldn't hear you.
A third part? Do you have
No, that's it.
It was a 1-point third part, so it must be pretty easy.
Well, we did this one, hence the equation is this.
Part to it.
Yeah, that's it. It's the same thing. That's it.
We already did that. didn't we?
Yeah, we did it. Yeah, I did it. Yep.
Wait, what?
Wait, no,
How did we do
It's a 1-pointer, hence solve the equation.
Yeah,
We
what,
solved it,
what,
right?
what does that mean?
Well, okay. I got it down to this here, right? So it's going to be 2 and then plus or minus 1/4, right?
We have an x value though, don't we?
Yeah, okay. I wanted to get much. Do you all agree with me? Yes? X minus 2 and then 4x minus 1 quantity squared. Yes?
Oh.
Set it equal to 0. So that means you get a 2, and this is plus 1, right? And then you set this equal to 0, and you're going to get what? Minus 1/4. Now, if you put minus 1/4 in that log junk, no go. It kills off the, can't have a log that's negative. So the only answer is this guy right there.
So we solved it.
It's extraneous, so that's you solve.
So
Mr. Epler.
we just plug 2 in.
You just plug 2 and call it a day. If you get a negative, right, throw it away.
Okay.
It's extraneous.
So the answer to part II was just the x minus 2 times worst plus 1 squared.
The answer to II is this one right here times x, right. And then the answer to triple I is this guy right here.
Okay.
Because you had to plug it in, right? And if you put 2 in there, it's going to be okay. But if you put minus 1/4 in there, you're going to get a negative side and a positive side off. Won't work. And you're going to get error here because the logs can't be less than 0. Okay? Domain error blows up. Okay, not bad?
Not bad.
Not bad.
I understand it.
I do too. So they paid me the small ones. All right. Hopefully the trap one is not bad. It's you guys already know how to integrate. Okay?
It looks like a type of iteration.
Oh, he's flattering me. Okay, absolutely, Mr. Tribble, it is. Okay. Any questions on this one?
Yeah.
All right, and I'll let you guys practice a trap. All right, working our trapeziums. Okay, so trapezoidal, trapezium. Sometimes it's called numerical numeration. Really, it's called that. Numerical methods. Okay, sometimes it's called, believe it or not, numerical addition. I've seen it written. So it's just another way of introducing integration without using the integral. Okay, Leibniz integral. Okay, not Newton, Leibniz. I'm a big Leibniz fan. Even though Newton's brilliant, Leibniz was something else, and Newton tried to ruin him. And he actually did pretty well, because he was the president or the founder of the Royal Society of Math and Sciences. You know, and he wanted to do everything because Newton said, "I devised this stuff up first." Leibniz, we use all his stuff more than this delta x anymore. We use the dx and the funny looking d for partials. You didn't do that yet, but you get d dx and so on. All that stuff is Leibniz more than Newton. Needless to say, we're going to do something which is called a continuous function between a and b. The first thing we're going to do is to find out, based upon wherever the curve is, we're going to have like this little bit of error that's associated when we just do this rectangular thing or a, what is it called? Trapezoid, okay? I do have stuff in the back, okay? I'll let you guys get that later on. I do have the answers to some of them as well, and so on. So this is just a big boring lecture and so on, all right? So the biggest thing is the function has to be continuous between the intervals or the limits of b to a, and it has to be continuous, and then they will give you the subunits. Divided into 5 subunits. I'm like, oh, okay. All right? That's what they'll tell you. All right? And then they'll tell you the round and so on. Well, if you think about it, let's say the function looks something like this, and then you're doing actually, you start off at the beginning, it could even be at 0 or whatever, and I show this right here, okay? You're taking this like a rectangle, but it's really a trapezium, okay? Or a trapezoid, so to speak. And then there's this different length between y0 and y1, and the width is delta x. And this little separation is what we're always going to be missing based upon the trapezium. So all we're doing is, you notice, guys, look at that. It starts off with the initial value, whatever it was, and then it keeps repeating the y1s, the y2s, the y3s, and so on, and then we're dividing it by 2. Okay, so it's really just the width over 2, which is called the first plus the last times 2 of all the other guys. Now that's a fancy way of doing it. Because if you think about it, see, this guy keeps repeating. y1, y2, y3, yn keeps repeating. So that's why it's double this one. All right? So, okay.